Welcome back. Today's going to be hard to top that tearjerker of a commercial yesterday and the connections that you undoubtedly had with your patients, and combining that with telomere study that Dr. Brian shared with us on Monday. I want today to just build a little bit more of a framework of what a telomere is and why it's important in our genetics. So let's tune into this brief 2-minute video from Dr. Lipton, and we'll discuss after.
So as you can see in this illustration, the red part of the DNA, that's where the gene programs are. But at the very end, the green part on that DNA is the extra extensions called the telomeres. And I say, so okay, why do we have telomeres? Well, here's the most important reason of all. Because when the enzyme comes in that copies the DNA, called a polymerase, it's like a train that lands on the DNA as the tracks. And as the polymerase moves down the track, it leaves behind it in a wake a copy of the DNA that it was riding on. So as the train is moving down the DNA strand, it creates a duplicate piece of DNA behind it. This is how the DNA is reproduced. But the serious part is this. When the enzyme gets to the end of the strand, guess what? It cannot copy the piece of the DNA that it's sitting on, because the next move, that enzyme, that little train will fall off the track. So why is it important? So as you see, when the polymerase enzyme lets go of the DNA, the new piece of DNA is shorter than the first copy. And I say, why is it relevant? Because every time the DNA is copied, the last little piece can't be copied. So every time it's copied, the DNA gets shorter and shorter and shorter. And then what will happen is, well, if you run out of the telomere portion, the next time you copy the DNA, you're going to cut off a piece of the gene. And that's when aging, disease, and depression begin, is when the DNA runs out of telomere.
Fantastic. Now that you all have a greater understanding of what a telomere is and why it's important to the longevity and youthfulness of our own bodies, we want to touch base on telomerase. It's the enzyme that he talked about at the end. This enzyme acts as a biological catalyst. This enzyme acts to add on to the end of that telomere to make it longer. So when a patient asks me, well, how does an adjustment do that? What happens in my body after you deliver an adjustment that helps my telomere grow in length 8.2%? Well, I think we need to look at what inhibits telomerase and what facilitates it and activates it. And a lot of those are the same thing on opposite ends of the spectrum, right? So, of course, what inhibits it and turns it off is ultimately the nervous system's inability to respond to external and internal stress. Of course, an adjustment aids in that process. Do you know what's really important to the times right now? What also inhibits polymerase? Isolation and loss of love, lack of movement. Those are the three biggies. You can use those exact same things when you're doing them well as to why polymerase is turned on and adds to the length of the telomere. What does an adjustment do? What did that young lady, that 35-year-old in the study on Monday go through? She went through 36 movement-inducing adjustments that helped activate the executive center in her brain, bringing her more hope and more purpose in life. Of course, these are so important. They're the equivalent of the fountain of youth. As chiropractors, we should be shouting this from the rooftop. Who cares about back pain and radiculopathy and headaches when the activities and care that we're providing in our office can turn on an enzyme, turn on telomerase that can add to the length of your telomere, therefore adding not only years to your life, but life to your years.